Hello, this is Topolgin, and today we're going to talk about a calculator for the weight that gives us the weight of different types of steel, different types of metal, sorry, and in various different shapes. And the most common shapes used in manufacturing or shops around the world, basically. And so as always, in any user-defined input, any variable that we need to input for our formulas to work are in yellow fonts and green cells, green background. So from the drop-down menu, we can select any type of metal we want. Right now we have steel, but we can change it to aluminum or whatever. And the wording over here for the constant density of aluminum in pounds per cubic inch. So the wording changes to aluminum in all of our different calculators for the various different shapes. So to if I go back to steel, the wording changes and obviously the number, right? The constant changes as we can see. Let's use steel for now for our example. And the most common shapes of the most common forms in which this metal come are sheet stock, bar, round tube, piping or ring, whatever you want to call it, square tube, piping or ring, and least common, but we can find them is hexagon bars or octagon bars. In our example here, we say that we have this length 15 and some change inches, right? Everything has to be in inches to work. So when we multiply by the constant, which is in pounds per cubic inch, we can get the weight in pounds. So everything, all the variables have to be in inches. So for sheet stock, in this example, we say, well, it's 15.81 inches in length and it's got a width of 6 inches and some change. And our thickness, let's say, is this gauge, and we have a maximum and a minimum. If we don't have a maximum and a minimum, we just have one that is decimal, we can, like in this example, put it in both areas as the same. And what it will do is average these two numbers. And in this case, our average is this 0.186. But in this case, the average is obviously going to be the same number, 0.188. So those are the considerations for these calculators here. So we already saw our length and our width, our gauge, maximum gauge, minimum gauge, and then we have our constant, which we selected through selecting the metal, and we have this weight in pounds. So this weight in pounds is what we can say our piece that according to the print, it's got these dimensions, and we're gonna cut out whatever any shape from here. Well, we need to charge our customer consumption. We need to put this in our bill of materials, in our ERP. This becomes our standard per piece for this piece that is going to be cut out from here, or maybe this is the piece, right? That we're going to need that gauge and those dimensions. So that's the standard way we need to use, and that is going to be very, very close to reality. So at the end of the year, we don't have to make many adjustments to our inventory for inventory discrepancies and the way that they affect uh, the reality on the floor versus the system, what we're charging or not charging to the customer. Either we're very competitive in our prices, very realistic, very cheap in our prices, and we're basically giving away a little bit of money on that cost if we don't calculate right away, or if we are charging more than our competition because we calculated the weight wrong and we're saying we consume more, then we're losing opportunity. Or maybe the competition is very efficient at cutting it better, Maybe they're cutting it at 14 inches. So we need to know that. We need to know reality in order to start advancing toward being more effective and efficient. So anyway, this calculator can be used by many departments: bill of materials, cost accounting, manufacturing engineering. Anybody can use it, even production. So they are the ones that suffer day to day all those discrepancies and adjustment. Maybe the prints are wrong. Maybe the bill of materials was set up wrong. So this is used also for that. So another variable, another format that this material comes in or can come in is a wire or a rod or circle bar. It's got many names. And in this case, we have the scenario of just the gauge, minimum and maximum, and the length. And basically, what we do is calculate the area of the circle and then multiply by the length, which is the volume of this cylinder in inches again. And then we have our constant weight of steel. And we end up with 0.385 pounds, basically. This piece with these dimensions, excuse me, is going to weigh 0.385 pounds. If what we have here, excuse me again, is a round pipe or a tube at these dimensions again, these inputs, well, we do all our calculations and we end up with almost 11 pounds. What we do here is very similar to what we do here at the bar with this bar is we calculate the volume for this cylinder with the outside diameter, and we calculate the volume of this imaginary or air cylinder. It's just full of air with this inside diameter, and we subtract this cylinder from the outer cylinder, and we end up with the volume of metal used in that cylinder. Only the metal, not the empty space, obviously. And then multiply by our constant, and that's how we get our weight. We do a similar thing here for this rectangle. In this case, it's rectangular. It could be square if we put, 1 inch as one of the sides. But let's say it's a rectangle here. So what we do is we get basically the bar volume with those outside dimensions, and then the inside dimensions would be whatever our height is, which in this case is 1 inch, minus 2 times the gauge. And same thing with the width. It's going to be 2 inches in this case, minus 2 times that width. So we subtract this internal bar from the external one, and we end up with a square tube, and we end up with almost 14 pounds at those dimensions. Similar to the round or the rod or the wire, we have here bars which come in hexagon presentation and octagon presentation. And what this is uh, these bars have the hexagon polygon and the octagon polygon have their very specific formulas. I don't wanna go through them here, but you can check them online. That's your homework. And basically through those formulas, you get the volume of these bars. And again, you have the volume in inches, so you multiply by the constant weight of that metal. In this case, we continue with steel. Same thing with the octagon. And I again did a little bit of visual here, so you know what you're inputting. And that's our calculator. Thanks for watching. See you on the next video. Top Bill Sinolgin signing out.